In a stunning U-turn on old data collected in the 90s, NASA have now revealed that Jupiter's moon Europa could in fact have life on the surface. Wait till you hear this. Scientists re-examining data from an old mission brings shocking new insights into the tantalizing question of whether Jupiter's moon Europa has the ingredients to support life. The data provides independent evidence that the moon's subsurface liquid water reservoir may be venting plumes of water vapor above its icy shell. Data collected by NASA Galileo spacecraft in 1997 were put through new and advanced computer models to untangle a mystery, a brief localized bend in the magnetic field that had gone unexplained until now. Previous ultraviolet images from NASA's Hubble Space Telescope in 2012 suggested the presence of plumes, but this new analysis used data collected much closer to the source, and it's considered strong, corroborating support for plumes. The best way to confirm there's life on Europa is to actually take samples from the interior of the Jovian moon. And NASA's Europa Clipper mission, to be launched in 2022, may help scientists solve the mystery of Europa. The hidden waters of Europa have become a major goal in the search for extraterrestrial life, and sending a spacecraft to take a sample of that type of geyser could be the most practical way to verify it. You have to wonder the point of finding another world close by which could hold life. Is this for us to terraform in an effort that slowly sees humankind leave the Earth and eventually leave the solar system? A stepping stone, perhaps? There must be a reason, right? They are certainly investing enormously in an effort to find such a place. Anyway, guys, what do you make of this announcement from supposed old data? Could it be the world was not ready in 1997 for a public release? Let us know what you are thinking, and thank you for watching.
Europa is the most likely place to find life in our solar system today because we think there's a liquid water ocean beneath its surface. Now we know that on Earth, everywhere that there's water, we find life. So could Europa have the ingredients to support life?
We might be actually looking at a body that is presently alive, presently active, and presently undergoing its geology. There is too much evidence right now lying around on the surface, the red stuff, that suggests that something's going on there. Is that an environment that is habitable for any sort of life form? By golly, we really have got to go back and figure that out.
We have designed the Europa mission to take a spacecraft and its set of instruments all the way from planet Earth to Jupiter.
Previous mission concepts were for a spacecraft that would orbit Europa, but Europa is bathed in radiation from Jupiter. Any mission that goes in the vicinity of Europa is cooked pretty quickly. Instead, we're looking at a mission that will orbit Jupiter, make close flybys of Europa, and then zip out of the high radiation region.
Kind of like when I was a kid, we had the sprinklers, and we didn't want to be too close to the sprinkler head, so we would run in and get a little water and then run back out again.
This allows us to have a mission that's many years long and to collect and transmit lots and lots of data. As Europa orbits Jupiter, it flexes, and we could measure the gravitational change of Europa by encountering Europa at different points in its orbit. On a typical flyby, we would turn on our remote sensing instruments, we would image the surface, we would interrogate the surface with spectroscopy, and we would do the same thing on the way out. And we would essentially rinse and repeat, and do this many, many times until we understand Europa globally. Images from the Hubble Space Telescope tells us that Europa might be erupting plumes of water high into space. If that's true, then we could fly through those plumes with a spacecraft and literally taste it to understand the composition of Europa's interior.
If it does have the ability to harbor life, how does that work exactly? We'll have enough instrumentation to really pinpoint exactly how the mechanisms would work for replenishing the nutrients in a subsurface ocean.
Europa is so important because we want to understand, are we alone in the cosmos? If there's life in Europa, it almost certainly was completely independent from the origin of life on Earth. That would mean the origin of life must be pretty easy throughout the galaxy and beyond. We didn't know till today that there's evidence from years ago that there's something there. Europa is one of the most fascinating bodies in the solar system. We think beneath its icy surface is a global ocean, twice the volume of all of Earth's oceans combined. In the late 1990s, the Galileo spacecraft explored the Jupiter system. It made about a dozen flybys of Europa. It took observations from its cameras and from its magnetometer.
By discovering that there was an induced magnetic field at Europa, we were led to the conclusion that there must be an ocean just beneath the icy surface of the moon. But there were some strange signatures in the magnetic field that we had never really been able to account for.
Images of Europa from the Hubble Space Telescope have hinted at gases that might have come from plumes erupting at Europa.
The Hubble images had given an estimate of the height and width, and I knew how fast Galileo was moving relative to Europa.
There are better tools now, better computational techniques, better computing, that we can go back and look at that old data set anew.
So my colleague Shinja Jia set up a calculation to see what would happen in the environment of Europa if there were such a plume. And when he ran this simulation, it agreed just beautifully with the data that we had collected.
Reanalysis of the Galileo magnetometer data suggests that the Galileo spacecraft, on its closest flyby of Europa, flew through a plume. The Europa Clipper mission is going to explore Europa to investigate its habitability. If we find active plumes, then we can sail on through them and sniff and taste that stuff that's in the plume. We can analyze the particles and the gases to get at the detailed composition of Europa's interior.